So, in 10 years, celebrating a billion-dollar company might actually be like throwing a parade just because you successfully tied your shoes.
Yeah, which sounds completely absurd today.
Right. But today, we are doing a deep dive into a financial projection that is so aggressive and, frankly, so relentlessly massive that it practically breaks our current understanding of mathematics.
It really does. I mean, we are pulling apart this highly speculative but intensely structured piece of analysis from mid-2026.
Yeah, it's titled Netizen, 1,000 Solaras in 10 years.
Hmm.
And the author isn't looking at billions, they're looking at trillions.
Right. They are projecting the rise of 1,000 companies, each worth $1 trillion by the year 2036.
Which is just, it's mind-bending. Why should you, the listener, even care about this? I mean, it sounds like finance bro fiction.
Well, because it is the absolute definition of an economic paradigm shift. If this framework, what the author calls the age of abundance, is even partially accurate, it represents a ground-up rewiring of how you live.
How you work, how you shop, everything.
Exactly. We are talking about a multi-trillion-dollar shift driven by this unprecedented convergence of artificial intelligence, robotics, and advanced physics.
To put that in perspective for you, right?
Yeah.
A billion-dollar startup is a unicorn. It's rare, but, we see them.
Yeah, we have a bunch of them.
But a Solara is a supermassive star. It is a celestial body so dense with capital and utility that it pulls entire solar systems of supply chains, human behavior, and infrastructure right into its gravitational orbit.
And as of today, the public market only has a handful of true trillion-dollar firms.
Right, like maybe 5 or 6,
Yeah.
and this author is predicting 1,000.
Which is why the underlying math of this report is the very first thing that hits you.
Yeah, let's unpack the math, because there are currently, roughly 1,300 to 1,700 unicorns globally right now?
Depending on the metric you use, yeah,
Yeah.
somewhere in that range.
Yeah.
So to project 1,000 Solaras by 2036 means we aren't just expanding the global economy.
We're multiplying it.
Multiplying it by an order of magnitude. The whole thesis hinges on 3 core drivers.
Okay, what are they?
Agentic AI, physical AI, which means embodied robotics, and what the author terms combinatorial explosions.
Wait, hold on. I have to push back here on behalf of anyone listening. $1,000 trillion company.
I know, the math sounds totally impossible.
The math simply doesn't work under our current economic physics. If we generate $1 quadrillion in new market cap in a single decade, wouldn't we just see apocalyptic inflation?
That is a very fair point.
Like, you can't just print $1,000 trillion without fundamentally devaluing the currency it's measured in.
Right, and that is actually the central tension of the entire analysis. But the author's defense is that these Solaras will not be traditional companies.
Meaning what exactly?
They won't just be capturing a larger slice of our existing economic pie. They will be massive infrastructure platforms creating an entirely new deflationary economy.
Deflationary. Okay, so things get cheaper.
Way cheaper. We are talking about the space economy, the longevity economy, planetary scale climate engineering.
So the argument is that the technology becomes so wildly efficient that it drastically lowers the cost of goods and services, which offsets the inflation.
Precisely. It requires a massive surge in global productivity that you only get by decoupling human labor from economic output.
Okay, I mean, that makes theoretical sense.
Now, the text is very clear-eyed about the attrition rate, right? Not every single startup aiming for this is going to hit $1 trillion.
Obviously, there will be massive consolidation.
Exactly. Thousands will fail. But the addressable opportunities, like the total market value of completely solving global logistics or curing cellular aging, they mathematically support this mega cap vision.
Because the value pool is undeniably there. If you cure aging, you're worth $1 trillion.
Without a doubt.
Yeah.
So to understand how any single company reaches that supermassive scale, we have to start with the foundational intelligence making it possible.
The brain of the operation.
Right. The blueprint projects between 50 and 150 Solaras emerging just in the foundational AI and agentic platform space.
And they aren't talking about, like, simple chatbots here.
No. They are talking about universal agent operating systems. The evolution here is from AI as a tool to AI as an autonomous actor.
The text describes it as an android for agents. Yep.
Yes, exactly. This is a foundational software layer where billions of specialized AI models run, coordinate, and negotiate across digital and physical environments.
Think about the smartphone revolution. I mean, the hardware existed for a while, but it wasn't until the operating system and the App Store were introduced that the mobile economy truly exploded.
That's a great analogy.
But an app is static, You tap a weather app, it shows you the temperature, and it just goes back to sleep.
Right, it doesn't do anything else.
But the agent marketplace, described in this source, implies you are effectively leasing autonomous digital employees.
That's the key distinction for you to understand here. These multimodal foundation models, they possess agentic reasoning, they have long-term memory.
And built-in tool use.
Exactly. You don't prompt them to draft an email. You deploy an agent into a digital ecosystem with a broad objective.
So it's not write an email, it's plan my vacation.
Yes. And it has its own wallet, its own cryptographic identity, and its own reputation score.
Which means, theoretically, you could have an agent managing your dynamic stock portfolio while another one is constantly hunting the internet for better interest rates on your mortgage.
Simultaneously.
Yeah, and a third one is handling your complex travel logistics.
Mm-hmm.
And they're all communicating with the airline's agents, the bank's agents, negotiating these micro contracts in milliseconds in the background.
It's incredible. But that level of autonomy introduces a terrifying vulnerability, which the source heavily highlights.
Right, the massive bottleneck of AI safety and alignment.
Yeah. When you have billions of non-human entities executing financial transactions, signing legally binding contracts, and allocating physical resources, safety ceases to be this theoretical ethics debate.
It becomes foundational infrastructure. Because if an agent with access to my biometric data and my financial accounts suffers a logic hallucination.
Or gets socially engineered by a malicious agent.
Exactly. The fallout for you personally is instantaneous and catastrophic.
Which is why the text projects that companies focus purely on AI safety and alignment will become Solaras themselves.
The safety cops become trillion-dollar companies.
They have to. We need provable mathematical guardrails. We need simulation sandboxes.
Where an agent's code can be stress tested.
Right, against millions of adversarial scenarios before it's even allowed to interact with the real-world economy.
So these safety firms will essentially provide the digital trust fabric.
Yes, because without an unhackable verification layer, this entire agentic ecosystem just collapses under its own risk profile.
Okay, but a brilliant digital brain trapped in a server farm can only generate so much real-world value, right?
It needs to interact with the world.
Exactly. A fully autonomous supply chain agent is totally useless if a human still has to physically load the actual cargo onto a truck. The intelligence has to bleed into the physical world.
And that physical manifestation is the next massive sector in the blueprint. Humanoid and embodied robotics.
The projections here are staggering. They're predicting up to 200 potential Solaras just in robotics.
It's huge. This spans from mass-produced, general-purpose humanoids, kind of scaling up from early prototypes like Tesla's Optimus.
Right, affordable units for domestic and industrial use.
Yeah, all the way to highly specialized fleets for agriculture or even microsurgery.
The really interesting structural insight the author points out here is the decoupling of the physical robot from its intelligence.
This is crucial. It's a complete hardware-software split.
Meaning you don't have to build the robot and code its brain.
Right. You could have companies building the titanium joints and the physical actuators while they simply license the robot brains from a completely different company.
The advanced perception and locomotion model.
Exactly. It's basically the Microsoft Windows model applied to kinematics.
So a single highly advanced spatial intelligence model could be licensed to operate a bipedal robot in a hospital, right?
Or a tracked vehicle in a mine.
Or a quadcopter inspecting a bridge. It's the same brain in different bodies.
Exactly.
I do struggle with the timeline on this a bit, though. I mean, we've been promised useful home robots for decades.
Oh, absolutely. The hype has always outpaced reality.
The reality is, Moravec's paradox is brutal. Doing complex math is easy for a computer, but getting a robot to fold a fitted sheet in a messy, unpredictable living room, that is a nightmare of spatial reasoning and tactile feedback.
It is remarkably difficult.
So are we actually going to see multi-trillion-dollar robotics markets by the 2030s?
Well, the author argues the timeline is totally viable specifically because of synthetic data generation.
Explain that for us.
We're no longer trying to hard code robots with line-by-line instructions on how to recognize a towel. We're using AI to build hyper-realistic physics simulators.
We're talking about a virtual world that perfectly mimics gravity, friction, and material shear stress.
Exactly. Inside these massive data and simulation infrastructures, which, by the way, are their own category of future Solaras, a robot's neural network can practice.
Practice in the Matrix.
Yeah. It can practice folding millions of mathematically distinct towels in millions of dynamically generated rooms.
It fails, learns, and iterates at the speed of compute.
Right. It executes what would be a century of physical trial and error in a single afternoon. So by the time that software is downloaded into a physical chassis in your house, it has already mastered the chaotic physics of the real world.
Okay, that actually makes perfect sense.
Oh.
And it scales way beyond just a single humanoid in the kitchen. The source details swarm robotics,
Oh, swarm robotics is fascinating.
because you don't build one giant, incredibly complex machine to fix a bridge. You deploy a swarm of 1,000 microdrones.
Right. They share a distributed intelligence.
Yeah, they communicate via local mesh networks, and they construct or repair structures collaboratively, much like a hive of insects.
And it creates incredible resilience. If one drone in a swarm fails or gets hit by a bird, the hive barely notices.
The collective intelligence adapts instantly.
This is particularly crucial for disaster response or environmental repair, where the terrain is just inherently hostile to large, single point of failure machines.
So we have the digital agents executing the high-level logic, and we have the embodied robots executing the physical labor.
Right.
What happens when you combine those and aim them directly at the global supply chain? You get the third massive category, agentic commerce and the personalized economy.
This is where things get really crazy for the average consumer. The blueprint anticipates 60 to 150 Solaras orchestrating this shift.
Because it fundamentally re-architects how value is actually exchanged.
Yes. At the macro level, you have agentic B2B marketplaces. Global supply chains will be fully automated.
Agents predicting demand, procuring raw materials, drafting dynamic contracts.
And routing shipping logistics without any human oversight at all. The text estimates this alone will command $3 to $5 trillion globally by 2030.
Let's bring that down to the consumer level, though, because this completely eliminates the friction of traditional commerce for you and me.
It changes everything about how we buy things.
Right now, retail heavily relies on mass manufacturing. Companies basically guess what millions of people might want to buy. They build it in a massive factory in Asia 6 months in advance.
They ship it across the ocean.
Yeah, and let it sit in an enormous warehouse just hoping you'll eventually click add to cart. It's incredibly wasteful.
So much waste of material and energy. So the text proposes a pivot to hyper-personalized, zero-inventory manufacturing.
We stop predicting mass behavior and start responding to individual real-time need.
Exactly.
Imagine your personal health agent, which is continuously analyzing telemetry from your smartwatch or smart ring.
It detects that the tread on your left running shoe has worn down.
Right. It realizes this asymmetry is causing a micro strain on your IT band. You haven't even felt the pain yet, but the data sees it coming.
In a zero-inventory economy, your agent immediately communicates with the design model.
Okay, so it designs a fix.
Yeah, that model generates a brand new CAD file for a shoe, altering the lattice structure of the midsole specifically to correct your unique biomechanical load distribution.
Wow. And then what?
Your agent negotiates the manufacturing cost with a local, automated 3D printing microfactory in your city. It pays for it using a pre-approved budget.
And a drone delivers a perfectly bespoke, medical-grade athletic shoe to your door a few hours later.
Exactly. And the incredible part is that the shoe literally didn't exist anywhere in the world until your agent willed it into existence.
Nothing sat in a warehouse. There is zero wasted material.
This extreme personalization extends to the digital realm as well. The author points to the AI, AR, and VR creator economies.
Moving toward dynamically generated media.
Right. An entertainment platform won't stream you a movie that was filmed 3 years ago with a set script.
It will render an immersive interactive narrative tailored in real time to your specific psychological engagement metrics.
It's bespoke entertainment.
But listen, there is a fatal flaw in this hyper-personalized zero-inventory dream.
The power grid.
Exactly. You cannot run billions of autonomous agents, render infinite virtual worlds, and coordinate global robot swarms if the electrical grid collapses.
Which brings us to the ultimate physical bottleneck: infrastructure, compute, and climate tech.
The projections here are really robust. They estimate 40 to 100 Solaras dedicated to AI infrastructure alone.
And another 50 to 130 focused on the climate and energy required to actually sustain it.
Because the companies that solve the energy and compute density crisis will inherently become the most valuable entities on the planet.
They hold the keys to the entire age of abundance.
The source outlines a massive necessary evolution in hardware stacks. We can't just keep building larger silicon chips, right?
No, we hit physical limits. The text specifically highlights photonic and neuromorphic computing.
Explain photonic first.
Well, currently, moving data using electrons over copper wires generates immense heat.
Right, data centers run incredibly hot.
And it hits physical speed limits. Photonic chips use lasers. They move data using light, which drastically reduces the thermal footprint and increases bandwidth exponentially.
And what about neuromorphic engineering? That sounds biological.
It takes inspiration from human biology. Traditional computing constantly shuffles data back and forth between memory and processing units, which is highly inefficient.
It burns a lot of energy.
Neuromorphic chips use spiking neural networks, mimicking the actual synapses in a human brain.
Oh, wow.
They only consume power when a specific neuron fires. This allows for incredibly complex pattern recognition at a fraction of the current energy cost.
Which is vital if we are putting advanced AI brains into battery-powered mobile robots that need to walk around all day.
Exactly. You can't have a robot that needs to plug into the wall every 20 minutes.
Even with those efficiencies, the baseload power requirements for this age of abundance are astronomical. The text points to fusion startups, advanced nuclear,
Specifically small modular reactors, or SMRs.
right, and even orbital solar power. But SMRs are fascinating because you aren't spending 10 years building a bespoke, multi-billion-dollar nuclear facility.
No, you manufacture standardized, self-contained reactors in a factory.
And you just ship them on a truck to wherever a massive new data center is being built.
Furthermore, AI will be deployed to solve its own resource constraints. The author envisions agentic smart grids.
The grid itself becomes intelligent.
Right. The grid will no longer be a dumb pipe just delivering electricity. It will be a predictive intelligence, dynamically routing power, water, and cooling resources in real time across national infrastructures based on micro-fluctuations in demand.
I really want to highlight a brilliant architectural shift the author proposes here, which is decentralized and edge compute networks.
Oh, this is an elegant solution to the hardware shortage.
Consider the sheer volume of high-end processors sitting completely idle in electric vehicles parked in garages right now.
Or in consumer laptops overnight while people sleep.
The blueprint suggests the creation of a global, privacy-preserving mesh network.
So when your devices are dormant, their raw compute cycles are leased out to the network to help process agentic workloads or render simulations.
You essentially turn the global fleet of consumer electronics into a distributed supercomputer.
And you, the device owner, get compensated in microtransactions for your idle processing power.
It's brilliant. And this capability scales directly into climate engineering, too.
Yeah, if you have infinite intelligent compute and abundant clean energy, you can engage in planetary repair.
The source projects multi-trillion-dollar industries built around robotic direct air capture of carbon, autonomous reforestation swarms, and synthetic biology.
Synthetic biology is a massive leap.
Instead of extracting petroleum to make plastics or mining limestone to make concrete, AI models design custom microbes that literally grow sustainable biomaterials.
We transition from an extractive global economy to a generative one.
Which is beautiful. And once we master the generative capabilities of biology to heal the planet, that exact same technology pivots inward.
It targets the human body.
This opens up biotechnology, longevity, and human augmentation. The author projects 50 to 120 potential Solaras in biotech alone.
This is where the medical paradigm flips from reactive to predictive.
Because currently, our healthcare system is fundamentally a sick care system.
Right. You wait until a biological system fails, you exhibit symptoms, you go to a specialist.
Who makes an educated guess based on broad population averages.
And you are prescribed a mass-produced chemical.
But under this new framework, agentic systems continuously monitor your multi-omic data.
Your genome, your microbiome, your real-time blood chemistry.
The AI detects the earliest epigenetic markers of a disease state long before you experience a single symptom.
The text describes the robotic manufacturing of personalized drugs.
It's like having a miniaturized, hyper-advanced pharmaceutical lab sitting on your kitchen counter.
Exactly. Your continuous monitor detects a rising viral load or maybe a specific nutrient deficiency,
It sends the data to your home bioprinter.
which synthesizes a custom therapeutic cocktail precisely dosed for your exact body weight, metabolic rate, and current renal function.
And it's just ready for you when you wake up.
The industrialization of longevity goes even further than that, though.
Yeah, the source outlines the development of senolytics.
Drugs specifically engineered to hunt down and clear out senescent cells, which are the dormant, toxic cells that drive the aging process.
It also includes lab-grown organs, printed from your own stem cells.
which completely eliminates the risk of transplant rejection.
We are talking about engineering the end of biological degradation.
It's wild to wrap your head around.
But the blueprint doesn't stop at physical health, you know. It pushes into cognitive augmentation. The text places huge emphasis on brain-computer interfaces, or BCIs.
BCIs address the ultimate data bottleneck, the human interface itself.
Right now, we possess incredible computing power in our pockets, but we communicate with it by awkwardly tapping our thumbs against a piece of glass at, maybe a few dozen words a minute.
It's painfully slow. BCIs bypass the physical body entirely, creating high-bandwidth bidirectional link directly between your motor cortex and digital systems.
At first, obviously, this restores agency to people with paralysis.
Which is miraculous on its own.
But the text really explores the consumer applications. Human-AI symbiosis.
You think about a complex query, and the answer is returned directly into your visual field via an augmented reality contact lens.
Or piped directly into your auditory cortex. You can physically pilot a humanoid robot across the globe via a BCI link with zero perceptible latency.
Which naturally leads to the next category, education and augmented workforces.
Because when humans are symbiotically linked to AI, the entire concept of learning transforms.
We will see personalized lifelong learning agents that map your specific neural topography
to deliver information in the exact format your brain absorbs most efficiently.
The workforce of the 2030s isn't just humans competing against AI. It's humans vastly augmented by AI, operating at cognitive speeds we currently consider superhuman.
So we've automated the supply chain, stabilized the climate, cured cellular aging, and merged human consciousness with digital intelligence.
That's quite a checklist.
Where does a civilization even go when it runs out of terrestrial friction? The text points up. It expands into the space economy, mobility, and defense.
The projections here are fascinating. They see 30 to 80 Solaras in the space sector alone.
And this isn't about planting a flag on Mars for national prestige.
No, this is brutal, pragmatic economics. We are moving heavy industry off-world.
Which begs the question, why build a factory in orbit?
Because the physical environment of space, specifically microgravity and a near-perfect vacuum, allows for manufacturing processes that are literally impossible under the crushing gravity and atmospheric contamination of Earth.
Take Z-band fiber optics, for example, which the text mentions.
Right. If you try to manufacture them on Earth, gravity induces microscopic crystallization, which degrades the signal quality.
But in zero-G, you can draw fiber optics that are orders of magnitude more efficient.
The same applies to flawless crystalline structures for quantum processors or highly specialized biopharmaceuticals.
And you obviously don't launch the raw materials from Earth to build these things. That's way too expensive.
No, the source details autonomous asteroid mining.
Robotic swarms identifying near-Earth objects, landing on them, dismantling them for rare earth metals and water ice.
And then launching the refined materials directly to orbital manufacturing hubs.
It's an infinite off-world resource loop managed entirely by AI.
Then, coming closer to the ground, the mobility sector, which is projecting 40 to 100 Solaras, is entirely redefined by agentic routing.
We are looking at the end of personal vehicle ownership.
Absolutely. Global fleets of autonomous robotaxis and heavy freight drones will operate as a utility.
The vehicles communicate constantly, eliminating traffic congestion through mathematically perfect routing.
But with that much interconnected automated infrastructure, the vulnerability is existential.
Which brings us to the defense and security category, where the author expects 30 to 70 Solaras.
Because when everything from your personalized medicine printer to the orbital solar array is run by AI agents, cybersecurity has to be absolutely bulletproof.
The attack surface of the age of abundance is effectively infinite.
The text details the necessity of self-healing security.
Because traditional cybersecurity basically builds a wall and just hopes the hacker doesn't find a crack.
Right, but agentic cybersecurity acts like a biological immune system.
Autonomous cyber agents constantly patrol the digital infrastructure, actively hunting anomalies.
Deploying deceptive honeypots and dynamically rewriting code on the fly to patch vulnerabilities before they can even be exploited.
And on the kinetic warfare side, the logic of autonomous defense systems is honestly chilling.
It really is.
If one nation-state deploys a swarm of hypersonic drones coordinated by a unified AI intelligence, and the opposing nation is relying on human pilots reacting at biological speeds,
The human pilots don't even have time to blink.
the decisions are made and executed in milliseconds.
Which is exactly why these defense platforms are practically guaranteed to achieve trillion-dollar valuations.
Geopolitics dictates that when an adversary upgrades to an agentic military, every other nation must instantly follow suit or risk obsolescence.
The government contracts alone will provide massive, immediate scale.
Up to this point, we've covered an overwhelming array of technologies. Hyper-personalized manufacturing, synthetic biology, orbital factories, continuous medical monitoring.
It's a lot.
But if you look closely at the timelines required to actually pull this off by 2036, classical computing simply cannot process that much data that fast.
It's physically impossible.
There's an underlying catalyst that makes this entire framework viable. The text calls it the force multiplier.
This is the linchpin of the entire document. It is the physics breakthrough that makes the math of 1,000 Solaras possible. Quantum computing convergence.
As of mid-2026, when this analysis was published, we had firmly entered the hybrid quantum classical era.
The author notes that players like IBM are hitting verifiable quantum advantage.
Meaning quantum systems are solving specific, useful problems faster than any classical supercomputer.
Right, and they are targeting fully fault-tolerant systems by 2029.
The direct hardware market for quantum computers is actually relatively small, maybe $20 billion by the early 2030s.
But the economic impact, the value it unlocks across biotech, materials science, and logistics is estimated to exceed $1 trillion.
To understand why it's the ultimate force multiplier, we need to clarify what quantum computing actually does differently.
It fundamentally changes how we approach optimization and simulation. Classical computers process information in bits, ones, and zeros.
They solve complex problems sequentially,
Right.
testing one possible solution after another.
Right. If you want to find the lowest point in a vast mountainous topography, a classical computer essentially walks blindly around the entire mountain range, checking the elevations step by step.
It would take millions of years to map the whole range.
Exactly. But a quantum computer uses qubits, which leverage the principles of superposition and entanglement.
So instead of wandering the mountains,
A quantum algorithm acts more like flooding the entire mountain range with water. Using wave interference, it amplifies the correct answer, the deepest valley, while simultaneously causing all the wrong answers to destructively interfere and cancel each other out.
so it finds the optimal state in a complex system almost instantaneously.
Yes.
The author breaks this quantum convergence into three distinct pillars. The first is quantum agents, or agentic quantum computing.
This is where quantum mechanics supercharges the AI brains we discussed earlier.
The text specifically highlights QRL, quantum reinforcement learning.
When an agent is trying to optimize global shipping routes, it has to evaluate billions of variables. Weather patterns, fuel costs, port congestion, dynamic pricing.
Classical AI hits a wall there.
It does, but QRL allows the agent to evaluate the entire probability space simultaneously, achieving policy convergence at speeds that just seem magical.
The second pillar takes that processing power and puts it in motion. Qubots, or quantum-enhanced robotics.
Right. When a humanoid robot is navigating an unpredictable environment, say, carrying a fragile payload across a slippery factory floor, it is constantly running complex kinematic equations to adjust its balance.
And quantum computing enhances that real-time sensor fusion.
It allows the robot's perception system to instantly optimize its path planning and motor control algorithms, reacting to chaotic variables faster than the physical limits of the hardware itself.
The third pillar is how we actually deploy this, because, we aren't going to have cryogenic quantum chips in our smartphones.
No, absolutely not. The reality is hybrid systems.
So the architecture will be seamlessly integrated.
Classical supercomputers will handle the massive data storage, the user interfaces, and the general orchestration of the agents.
But when an agent encounters an exponentially hard problem, like simulating the exact molecular binding affinity of a new synthetic protein to cure a specific cancer,
it offloads that specific mathematical equation to a quantum processor in the cloud.
the quantum system solves it instantly, hands the answer back, and the classical system just continues its work.
But this incredible power has a very dark side, and the text is explicit about the security threat.
We mentioned the necessity of cybersecurity earlier, but quantum computing introduces a terrifying concept. Harvest now, decrypt later.
It is arguably the most urgent infrastructure crisis of the decade. Almost all the digital encryption protecting global finance, military communications, and critical infrastructure relies on mathematical factoring problems.
It would take a classical computer thousands of years to crack RSA encryption.
But a fault-tolerant quantum computer running Shor's algorithm can crack it in minutes.
Which means hostile actors don't actually need a quantum computer today to do massive damage.
No, they are currently intercepting and siphoning petabytes of encrypted databank records, state secrets, intellectual property.
They're storing it in massive data centers.
You can't read it yet. They're simply harvesting it now, waiting for the day when fault-tolerant quantum systems come online so they can decrypt everything at once.
It puts a ticking time bomb on literally every secret humanity currently holds.
Therefore, the transition to post-quantum cryptography is not optional. We have to completely re-encrypt the nervous system of the global economy before these machines scale.
And the companies providing that quantum-resistant security layer will absolutely achieve Solara valuations because their product is quite literally the preservation of global order.
They will be indispensable.
This entire deep dive paints a breathtaking picture. A world of infinite clean energy, hyper-personalized commerce, synthetic biological abundance, and robotic labor forces, all driven by quantum-optimized intelligence.
It's a utopian vision, honestly.
But we cannot just swallow the utopian vision without chewing on the reality. The author concludes with a necessary grounding, a reality check focusing on the hurdles, geopolitics, and the human element.
Because the projections are mathematically sound based on the tech, but the physical world is messy.
Yeah, the author cautions that deployment timelines will inevitably slip.
We will run into severe materials, shortages, regulatory gridlock, and unpredictable energy constraints.
You will see massive market bubbles, overhyped cycles, and spectacular corporate collapses along the way.
And you cannot ignore the geopolitical warfare. These aren't just consumer products. These technologies dictate national sovereignty.
The text predicts that many of these Solaras will essentially function as national champions.
The US, China, the EU, and India will heavily subsidize and protect these mega corporations, viewing them as critical defense assets.
The author also makes a crucial distinction about who actually captures this trillion-dollar value.
It won't necessarily be the companies that invent one specific piece of hardware. Pure-play quantum computing firms might struggle to capture the value they create.
The true Solaras will be the vertical integrators.
Meaning they own the entire stack, from the physics to the physical product.
Right, so a vertical integrator designs its own quantum processors to train its own proprietary foundation models.
Those models design custom therapeutics, which are then manufactured in the company's own automated biofacilities.
Utilizing the company's own robotic fleets, powered by its own microreactors.
They eliminate all external dependencies and capture the margin at every single step of the combinatorial explosion.
Which means the wealth concentration will be unlike anything in human history.
We are looking at a transition from an economy defined by managing scarcity, scarce labor, scarce energy, scarce materials, to an economy defined by managing abundance.
For anyone listening, this forces a radical recalculation of human capital.
If you are entering a decade where the most valuable entities on Earth are platforms for autonomous intelligence and generative physics, what is the value of your current skill set?
When an agentic system can master complex coding, financial analysis, or structural engineering in seconds, human economic value shifts entirely away from raw computation and processing.
It shifts toward high-level orchestration, empathy, and asking the right questions.
We started this deep dive talking about unicorns and how $1 billion was the pinnacle of success.
It seems so quaint now.
But looking closely at this matrix, AI designing proteins, manufactured by robotic swarms, managed by quantum-backed logistics agents, it becomes obvious why the author needed to invent the term Solara.
$1 billion is a rounding error when you are literally rewriting the physical constraints of reality.
The combinatorial explosion is really the defining concept here.
The magic doesn't happen just because AI gets smarter, or because robots get more agile, or because quantum computers get more stable.
The magic happens when all three technologies mature at the exact same moment and cross-pollinate.
It's an exponential feedback loop that accelerates innovation beyond human capacity to even track it.
We've mapped out the technology, the math, and the economic shift of these $1,000 trillion companies. But there is a massive philosophical void at the center of this blueprint.
A puzzle that the author doesn't even attempt to solve, but that we all have to face.
Right. If everything goes exactly according to this plan, if we achieve this age of abundance, if your personal agents handle all your logistics, if robots do all the manual labor, if synthetic biology cures disease and fusion reactors provide infinite energy What happens to the human drive for purpose?
For our entire history, human society, culture, and individual identity have been forged in the fires of surviving scarcity.
We completely define ourselves by our jobs, by the friction we overcome to just survive.
If the Solaras succeed in eliminating that friction, labor becomes entirely optional.
In a world where survival is a solved equation, and where your mind is augmented by symbiotic intelligence, what will you actually choose to do with your time?
Do we collapse into hedonism, essentially becoming pampered pets to our own autonomous infrastructure?
Or does the removal of basic survival friction elevate the human experience, allowing us to pursue exploration, art, and philosophy on a scale we can't even imagine?
It's like staring directly into a supermassive star.
The scale of it is blinding. The implications are terrifying. But the gravitational pull is absolute. There is just no looking away. Thank you for joining us on this deep dive into the blueprint of tomorrow's economy. Keep wondering.